started. Thanks for the introduction. So my teaching context is Chem 232-2, which is the second quarter of organic lab for the chemistry majors. And this year with the pandemic, we did a hybrid course structure. So we had 29 students total, 13 of which were online, and then 16 of which were in person. So with this sort of context in mind, I thought it would be a good opportunity to look at the differences between the online and in-person students. So my guiding research questions were: one, how well does online organic lab in comparison with the in-person lab prepare students to use basic organic lab techniques after the conclusion of the course? And then two, how do students perceive the course? Can we use student feedback to implement changes for future iterations of the course? So my guiding hypothesis for this project is that the online students will not feel as though they truly understand how to both set up and use basic organic lab techniques, as they do not have the chance to practice many of the techniques used throughout the course. And based on literature, I decided to collect pre and post surveys, ask them additional technique questions, look at their overall grades, and then also look at their lab reports. And what I did with the lab reports is I ranked them according to Bloom's taxonomy to give more quantitative data to qualitative lab reports. So the first thing I wanted to do is give an overview of the demographics between the online and the in-person students. Of the 29 students total, I had 26 respond to the survey. And so just looking at the overview, you can see that the general overview is pretty similar between the online and the in-person classes, meaning that we can pretty effectively compare the two. So I started by asking them how they felt that they benefited by taking the version of the course that they did. And we can see for the online students that the major category there was that the lab was shorter and they also had more time for data analysis. While the in-person students felt as though the hands-on experience was the greatest benefit, and it was also more engaging and exciting. One of these students specifically mentioned that it was they were able to understand how to do techniques more from doing them myself rather than watching a video about it. For example, it is hard to understand how melting point is found from the videos because it's usually just said. Before taking the class in person, I didn't know how the machine worked or how the sample was put into a capillary tube. So this hands-on experience theme is definitely one of the major benefits for in-person students. And if we look at the disadvantages, we can see that hands-on experience was the greatest disadvantage that online students felt as though they had. They felt that they don't really have the practice necessary to do all this in lab in actuality. And then some other disadvantages that they felt was that it was harder to write error analysis because they didn't do any of the experiments themselves. And they also had less opportunity for one-on-one feedback that the in-person students get constantly from the TAs and the instructors during the course. In-person students, on the other hand, felt that their biggest disadvantage was the biggest time commitment. Some of the comments that they had is that, it was harder in person and the data was worse, so I assume online lab people will get higher grades. They also spent less time doing the lab than us, so that kind of sucked. So the greatest advantage for the online students, being that it was less time, was also the greatest disadvantage for the in-person students, and vice versa. In-person students having hands-on experience was the greatest benefit, but also the greatest disadvantage to the online students. So one of the other things I did, I had them rank on a scale from 1 to 5 different organic lab techniques. So I have a list of 12 techniques here. The first 8 being more experimental lab techniques and the last 4 being more analysis techniques. And before and after they did the course, I had them rank how they felt before doing the course, how they felt about being able to perform the techniques on their own, where 1 is not at all and 5 is being able to perform with ease, and then how they felt after the conclusion of the course. And we can see here that what I found interesting is that the online students before, actually in almost every category, ranked themselves higher than the in-person students did before. So they felt like before the class, they actually had a better understanding than the in-person students. But after the course, almost in every category, the in-person students ranked themselves higher. So one of the things that I was thinking about, it kind of indicates to me that the online students may not necessarily know exactly how much they don't know, because since they never had the opportunity to do the techniques themselves, they ranked themselves higher because they might have just assumed they understood it versus the in-person students knew what they didn't know because they actually had the opportunity to do it. The other thing I want to point out is that these last 4 techniques, which are all more analysis, the after difference is much more even. Versus the experimental techniques, there's a lot more increase for the after between the online and in-person. And that's because these last 4 techniques are more analysis-based. So all of these students, both online and in-person, got about the same amount of practice doing these types of techniques, versus the experimental techniques, online students could only watch, versus the in-person students actually got to do it. In the post-course survey, I developed some additional technique questions to kind of probe their understanding for different techniques. So for example, I split these up based on the types of questions I asked, of which there were 10 total. So I asked about recrystallization, what they would do if their product wasn't crashing out, what solvents they might pick, how they might extract a product, how they might separate something with different boiling point or different polarities. I also asked experiment-specific questions. And what you can see by looking at this data is that the online and the in-person students performed about the same for these types of questions, except in the hypothetical separations and experiment-specific questions, which could make sense because the in-person students actually got the practice to do this in lab. One of the things that I would like to change in the future is ask more questions about the apparatus itself and how to set it up and how to use it, because I was asking more hypothetical and theoretical questions, which the online students do seem to understand, but I really want to get at whether or not they understand how to use the specific instrument and how to set up the technique and use it. I also used Bloom's taxonomy to rank their lab reports. So I looked at 2 different lab reports for the online and the in-person students, one towards the beginning of the class and then one towards the end of the class. And I split up the reports in terms of ranking by the reaction discussion, so looking at the mechanism, what types of conditions we used and why we had to use them, the data analysis, so looking at IR, NMR, mass spec, and then error analysis. So what went wrong, how they could fix it in the future. And based on Bloom's taxonomy, I kind of assigned everything a number so that I could assign a ranking to each lab report. So going up from remembering 1 through 6, and then if they didn't discuss it in their lab report, I ranked a 0. So over here you can see it's again kind of before and after. So nitration was one of the earlier lab reports and the glucosamine amine lab report was later. So you can see how they change. So the online students, there was very little difference between the lab reports. So this could indicate that they kind of started at a higher level and stayed at a higher level. But if you look at the data analysis and error analysis, the in-person students actually performed better, especially afterwards in terms of how they discussed and talked about everything, which makes sense because they were able to generate their own data. So they were able to analyze their data, they knew what was going on in the experiment, and they also knew how they could fix it because they knew it went wrong, which leads into error analysis. Reaction discussion was the only category in which the online students started higher and stayed higher. This, I would say, makes sense to me because they do have more time to get into the theoretical experiment, what's going on, why it works, why it needs to work that way, and so they were better at discussing that. So that was the lab reports. And then I also looked at their overall grades. So just right off the bat, you can see that the online students started with a higher distribution of A's. So these students generally performed better in the class. I also have the grades from fall and winter. So I'm comparing their growth from when everyone was taking the course online to when they split in the winter to half taking online and half taking in person. So for the online students in the fall, their average grade was about a B plus A minus, and then going to winter, they improved slightly to about an A minus average, versus the in-person students started at a little bit lower average, B to B plus average, but they improved all the way to a B plus A minus average. So even though their average was still slightly lower than the online students, there was a much bigger improvement. And this indicates to me that the in-person students might just be better at hands-on learning. So when they got the opportunity to do this themselves, they actually were able to learn better and it improved their grade. I also asked the students what their suggestions were to improving the course. So both the online students and the in-person students had some good suggestions. So for the online students, the major category was adding virtual interaction elements. Some students also suggested adding more spectroscopy review, designing their own experiments, or having fewer lab reports. Because these students felt as though the biggest difference between the online and the in-person class is actually just doing things, because it's somewhat easy to just coast through lab videos without fully understanding how to do something. So if there were simulations or something, that would be a nice supplement. And one student said, I don't think there is any real way to enhance this course because the only enhancement is to go in person and do lab, which hopefully we can work on changing in the future. And the in-person students felt that more focus on the lab techniques and making the course build off itself more would be useful. They said that it would be nice to focus more on lab techniques and carrying out experiments. They feel as though the majority of this class's time is spent on doing the same lab analysis many times, such as one HNMR analysis every week. Whereas understanding why different experimental conditions or procedures are chosen is not very emphasized. So this sort of comment goes back to the lab reports. The online students were understanding why we chose different conditions and why they were useful, which is why they got a little bit higher scores on the reaction discussion in comparison with the in-person students. And another student said, maybe make the lab course build upon itself more, not just the lab each week in a report. So in summary, going back to my question, so one, how do they compare? Online students feel less able to set up and perform organic lab techniques on their own. But looking at those additional technique questions, the theoretical knowledge for the online students was in alignment with the in-person students. And how do students perceive the course? Online students feel as though the course could be made more interactive with videos and/or simulations, as well as live feed for the experiments. And then the in-person course should focus more on lab techniques rather than repetitive data analysis. In future work I would like to do, look at implementing some of the changes suggested by the students and see how their feelings about different techniques and how their rankings change. I also want to develop a more interactive final technique quiz with apparatus setup to see if that affects their scores. And then I also have data for the analogous course for non-majors, which is Chem 230-3. So I'll be working on analyzing that data. And I want to thank everyone that helped with this project. So Professor Stephanie Nez was the professor for the organic lab course, and she helped a lot with designing this project and carrying it out. And then everyone who helped with the STAR project, so Lauren, Rob, and Nancy, as well as my STAR cohort. Thank you.